Welcome to the beginning of video 4 in the exponential and logarithmic chapter. This is on the properties of logarithms. You've gone over this in Algebra 2. This should be a review, but if not, this gives you a video that you can look at over and over again. Let's review the exponent rules that we have covered so far. M to the A times M to the B. Notice the M's have the same base. You would add the exponents. So I would have M is equal to A plus B. If I have M to the A divided by M to the B, same bases, then I would have M to the A, the numerator, minus B. A log is an exponent. So if I have something that says B, the base to the Y, power, is equal to a value, then to write that as a log, I would say the log of base B of a value equals the exponent. So the Y, both of those are the exponent. B is the base. And if you can put those two things in place, you can convert any exponent to a log just by knowing that the log is equal to an exponent and that the bases are the same. Here are the 3 log rules. These need to be copied into your notebook. I want you to notice that just as we had the rule for exponents, we said that if the bases were the same, we would add the exponents. Well, remember that logs are exponents. So if you are trying to take the log of a product, 2 numbers multiplied together, you would separate them by adding the logs together, just like you would for an exponential. For a quotient, where you have the log to the base B of m divided by n, you would separate that into 2 logs by subtracting the exponents. And the power function says this, that if you take the log to the base B of m to the n power, the actual power, the exponent of this log, could be multiplied times the entire log. In other words, an exponent multiplied times an exponent. Notice that I keep calling the log an exponent. If you can remember that, it will help you with some of these formulas. Be sure these are copied down in your notes. You should know them already, but they need to be in there for sure. All right, well, we'll use these properties to evaluate these logarithms. And the first one we want to do is the log to the base 3 of the 5th root of 3. So we're going to rewrite this as log to the base 3 of 3 to the 1/5 power. And we see here that we had learned previously that log to the base 3 of 3 is just equal to 1. But before we do that, we'll use the power property by writing the 1/5 out in front. And that 3 is kind of out in the middle of nowhere. But basically log to the base 3 of 3, this becomes 1. And so the answer is 1/5. This answer right here, we're going to use the quotient property by writing it as a single logarithm. And so that's going to be e to the 5th divided by e to the 3rd, which is the natural log of e to the 2nd power. Once again, the power property says that we can write that as 2 natural log of e. The natural log of e, because that is the inverse property, is just 1, and so this is 2. We can use the properties of logarithms to take apart logs. You see this log, the first log example, log to the base 4 of 3x squared y to the 3rd. Notice that I have log base 4 and then I have 1, 2, 3 pieces. So when I take this apart, I'm going to actually have 3 logs to the base 4. So that's what I'm doing. I'm just writing log to the base 4 3 times. This is the product rule, because they're all multiplied together, so that means that there will be pluses between. So the first one will be log to the base 4 of 3 plus x squared. Well, we also remember the power rule. So the exponent that would be here gets put in front. So 2 log to the base 4x. Still product rule, so that's a plus. And then I have y to the third power, once again the power rule, and we write the 3 in front. And so that's what you're doing, is you're just using the properties to rewrite these or to expand them. All right, here we have 2 properties as well. We have the quotient property, and because they are to a power, we have the power property. So I look here, log to the base 4, and then I have 1 in the numerator, a term in the numerator, and an term in the bottom denominator. And so I'm going to have 2 logs this time. So log to the base 4, and it looks like a Lloyd, doesn't it? No, I'm trying to write it. All right, and then log to the base 4. And in the first one, I have m squared, so the 2 comes out in front. This is a quotient, so there's a minus between them. Remember, when we had the quotient before with the exponents, it was subtracting the exponents. And then I have n to the 5th, and the power goes in front. So 5 log to the base 4 of m minus, 2 log to the base 4 of m minus 5 log to the base 4 of n. We can also use the properties to put the logs together. You can see that they're expanded here with a plus sign in between, with a number out in front of the log, and so you can see right here that we've got the product rule in reverse and the power rule in reverse. So we're just going to put it back together into one log. So I'm going to write 1 log, and it's log base 10, it's common log. It's plus, so this is going to be multiplication, no denominator. There'll be a 1 in the denominator. It'll be x to the 1/2 power and y to the 2nd power. So these are exponents, right? So they just go back on, that's the power. This is the product rule. So when you put it back together, it's multiplication. All right, so here's one, and it's kind of funny because I typed it in. Hopefully you can tell that all 3 terms have the same base. This is key here, right? The properties don't work if they have different bases. So this first one, I'm going to put them all together, and I notice I have a minus sign and I have a plus sign, which means I have both the product and the quotient property. Because there's a 3 out in front, I have the power property. So I'm going to use all 3 properties to put these all back together. So I'm going to write log to the base 3, and then I'm going to go ahead and draw a line here, and then I'm going to work left to right, just like you read. This first one here is x. Notice that this is the power rule, so that would be x to the 3rd. Now, it's not written here, but that's positive. You agree? There's no minus sign there. So that goes in the numerator. Here, this one has a minus out in front. So this is going to go in the denominator. That whole argument. And then the 3rd term here is also the power rule, but it has a positive, a plus in front of it. That means numerator. So I'm going to do y to the 1/2. And that's what that is, all put back together again, condensed into 1 log. So condensing means put together into 1 log. Expanding means to write them as individual logs. And there's reasons to do both. Sometimes writing them out, you can actually simplify them into something much simpler. Putting them together sometimes is easier to work with in a different way. Here are a couple of examples that I would like for you to work in your composition notebook. Have it ready. Make sure that you not only copy these down, but you take the opportunity to work them. Also, you need to double check that you're doing it correctly. If you're not doing these problems correctly now, you will not do them correctly later on. So please copy them in your notebook and work them before the next class. And one more screen, hang on. This makes me laugh. See if you can figure out what it says. And I'll see you in class. Bye, everyone.